If this person pushes the box with a 10 Newton force and the box doesn't move, then he will be thinking, well, the force that I applied cannot overcome the friction, so I need to apply a much larger force. And this is what happens when he pushes with a larger force. So to understand how the friction works, let's take an example. So we have a block on a rough surface, and we will apply a force on this block. And by default, the friction force will resist the motion of the block. And we are given the so-called static friction coefficient and kinetic friction coefficients. And let's do some experiment together. So we want to apply a force of 10 Newton, and then we want to see what's happening. So when we applied this force, nothing happened, no motion occurred, which means this system is under static equilibrium, or the summation of forces on this block is equal to 0, and this leads to the fact that the applied force is equal to the friction force. And if we increase this force and no motion occurs, again, this means that the friction force is exactly the same as the applied force. It's a static equilibrium, nothing is changing. And if we do that one more time and increase the force to 50 newtons and no motion occurs, this means again that the friction force is in static equilibrium with the applied force. And then you notice that by increasing the force to just 50.1, the block starts to move. And now the static equilibrium is not valid anymore. We have to apply Newton's second law, which is the summation of forces equals to ma. And now the applied force minus the friction force will be equal to m times a. However, you noticed also that the friction force dropped from 50 to 40. And when you increased the force applied to 80 newtons and the block moves faster, the friction force is still 40. Even faster, with 100 newtons, you will see that the friction force always have this constant value of 40 newtons. So what happened here that causes the friction force to drop and remains constant? And it's time to go behind the scenes to see what exactly and what physically happened. So this is our table. This is the free body diagram showing all the forces. And if we want to find the normal force, then we apply the summation of forces, which is going to be equal to 0. And this leads to the normal force, which is equal to the weight, or 100 newtons in this case. And by looking at our table, this is what is actually happening between the friction force and the applied force. So when we applied 10 newtons, we got 10 newtons of friction force. And when we applied 30, we got 30. And when we applied 50, we got also 50. And in all these situations, we are within the static friction region, which means there is no motion in this straight line. But at the top of this line, we reached the so-called maximum static friction, which is equal to mu s times n. So you can see from here, mu s is 0.5, n is 100, and the maximum static friction is 50 newtons. So what happened when we increased the force to 50.1? Now 50.1 is larger than the maximum static friction, which is 50. And this means that the block will start to move. And when the block started to move, the friction dropped because the kinetic friction is usually smaller than the static friction. So the kinetic friction now is mu k times n, which is 0.4 times 100 or 40. And as long as we are moving, even if we increase the amount of the force applied, the kinetic friction remains constant always at 40 newtons or at mu k times n. So physically, we have three situations. If the force or even other forces applied on the block are not enough to move the block, this means that the friction force is in static equilibrium with all other forces, and we can calculate its value from the summation of forces equal to 0. And if the block starts to move, which is our second situation, the friction force is known. It is equal to the maximum static friction, which is mu s times n. And in the third situation, when the system is moving with an acceleration, for example, then the kinetic friction is applied, which is mu k times n. So again, in the first region of the straight line, no motion occurs. It's a static friction situation. So the summation of forces equals to 0, and the friction force is unknown. We find it from the equilibrium. In the second situation, when the system starts to move, we have summation of forces equals to ma with the friction force value known as mu s times n. And in the third situation, the summation of forces equals to ma with the friction force equals to mu k times n, because we have motion and we have kinetic friction. And finally, to put that in some useful mathematical relationships, we will say the following. If the friction is less than mu s times n, no motion is occurring. If the friction is equal to mu s times n, the system is about to move. And if the friction force is equal to mu k times n, this means already that motion occurs and the system is moving.